This conference will now be recorded.
Very good evening, students. Today, in this PYQ discussion sessions, we'll be discussing the questions from JEE Main 2024 6 April Shift 1 paper. We have already discussed the paper on 5th April, 4th April, and now we are discussing the questions from the 6th April Shift 1. First we'll discuss, then we'll go for the questions from Shift 2nd. Okay, so let us start our today's discussions. So the first question says, for a given single electron, ratio of shortest wavelength in Balmer and Lehman series is 1:4, 4:1, 2:1, 1:2, etc. So you have to find out the ratio of the shortest wavelength of Balmer and Lehman series. So let me tell you how we get Lehman series. So suppose I have any arbitrary energy levels of a particular atom. Suppose you know n is equal to 1, 2, 3, 4, etc. You'll have, so these are the n is equal to 1, 2, 3, 4. These are the principal quantum number, and corresponding to each quantum number there will be corresponding energy levels, right? So when we get this kind of Balmer or Lehman series, when there is a transition, okay, when the electron makes transition from higher to lower, higher energy cell to lower energy cell, and then the extra or the energy gap, the energy amounting of the gap energy will be released as the photon. So that's how we get various hydrogen series like say Balmer series, Lehman series, etc. Okay, now in this case we'll see when we get Lehman series, we get Lehman series when the final cell will be nf is equal to 1, and initial cell can be 2, 3, 4, etc. How we get Balmer series? Balmer series we get when the final energy level is 2, whereas initial energy levels can be 3, 4, 5, etc. Okay, now we have to find out the shortest wavelength. Shortest wavelength means we have to have the highest energy gap or the maximum energy gap. Okay, so how do you get that? If see final level is not going to change, so what will be initial level in this case? So shortest wavelength for any series, shortest wavelength to get, see the initial stage, that means the electron taking transition from the initial state to the final state is n is equal to 1. So this has to be infinite. Okay, for any series, whether it is Lyman series or Balmer series, the initial state from where it is making a transition should be infinity. For that only will get the shortest wavelength. for that particular transition. Okay, now let me write how we write the expression for the wavelength. So we write the general expression. So general expression 1 by lambda is equal to r z square. This is general expression for hydrogen. We can write z is equal to 1. Then 3, this will be 1 over n final square minus 1 over n initial square. Okay, now see, if I write for Lyman series, the same formula will be like this: 1 by L. Okay, let me just keep this the original formula, and let me write this particular formula for shortest wavelength for Lyman series. Okay, Lyman series r z square. See, nf is equal to 1, so this will be 1 and 1 over infinity. Okay, so this is the thing. That means, you know, you are getting 1 over lambda L is equal to r z square. Okay, so what you get for Balmer series, let me write it here. So 1 over lambda b is r z square. 1 over nf will be 2, right? So 2 square minus initial will be again infinity. Okay, so let me just erase this expression here. And what I get here? I get r z square by 4. Now I have to get the ratio of shortest wavelength in Balmer and Lyman series. So let me write it here: 1 by lambda L over 1 by lambda B is equal to r z square Balmer by, okay, so fine, r z square divided by r z square by 4. So this implies, see, this implies lambda B over lambda L is equal to 4, right? This is equal to 4 because rz square can cancel each other. So I can write 4 by 1. That means 4 is to 1. Okay, so lambda B is to lambda L will be 4 is to 1. Okay, so option B will be the correct answer for this question. So what was the point to remember here? When we will get the shortest wavelength, okay, and largest wavelength you will get for the immediate one. Okay, suppose if the transition is 2 to 1, or in this case 3 to 2, this will give you largest wavelength. Okay, all right, so we'll go to the next problem. This is an interesting problem from electricity part. So you can see this is a Wheatstone bridge, right? The question says, for what value of unknown resistance X, the potential difference between B and D will be 0 in the circuit shown in the figure. See, in case of Wheatstone bridge, what we get? Let us compare this. Generally, we connect the battery between this two. This is AC, this is B and D. Okay, my figure is not that great, that's why. Okay, so that's why it is looking little odd maybe. And this is the galvanometer. See, when there is no current through this, okay, B to D, if there is no current through the galvanometer, then the breeze is said to be in balance condition. And if I name, see, this is generally named as P, this resistance Q, this resistance R, this is S. So when current is not flowing, that means I can say potential difference between, see, in this case, at balance condition. Actually, potential difference between B and D is zero by saying that it is saying that the circuit, sorry, Woodstone bridge. I think I am misspelling this. Let me just correct it. Woodstone bridge. Yes, I think it's okay. So Woodstone bridge is at balance condition, okay? When potential difference between B and D is zero. Okay, so guys, you can understand that the bridge given over here is then at the balance condition. So I can just compare. See, if I compare, then I get P is equal to 12 ohm, Q is equal to, see, 1. See, I have to get this equivalent resistance. So 1 into 1 divided by 2. So this is 0.5, or I can write half. And see, PQR, R is actually 6 plus X and whole, this is ohm, and S is again half ohm. Okay. Now at balance condition, what we know, P by Q is equal to R by S, right? So if I do the calculation, putting the values of PQ after comparing PQRS, excuse me, I'm just erasing this part. I hope you have understood this. Okay, so this implies 12 by half is equal to R by S, that means 6 plus X divided by this. So this I can actually cancel from both sides, and from here I get X is equal to 6, and this is in ohm unit, as you know. So option B will be the correct answer for this question. So here the bottom point is, or the important point which you need to remember is that when there is no current flowing through the galvanometer, then the breeze is at balance condition, and at that point the potential difference between this B and D point is also zero. Okay, that is why the current is not flowing through B to, like, current is not flowing from B to D. Okay, so this problem was given from Houston breeze at the balance condition. Okay, now let us solve this or answer this question. This is from optics. Okay. Which of the following does not depend on the wave nature of light? Look it here. Refraction of light. This is anyway that it is not related to wave nature. Diffraction of light. We have to use the wave nature of light to explain the phenomena of diffraction. Photoelectric effect, polarization, and interference. See, polarization, interference, and diffraction, these are actually the topic of wave nature of light. Refraction, ray optics. Photoelectric effect is the effect which doesn't matter whether it is wave nature, but anyway, this is actually quantum nature, we can say, or the particle nature. So photoelectric effect actually it is, I mean here, particle nature of light, particle nature of light has been considered. Okay, Einstein has explained photoelectric effect using the quantum mechanics and considering the photon to be pocket of energy or discrete, like a light is composed of discrete pockets of energy, those are called quanta, and that is actually indicating the particle nature of the light. This is anyway ray concept, and these are actually wave concept. And now let us see what, see the question says which of the following does not depend on the wave nature of light. See, only C, this is one option. Then A, B. A anyway does not depend on wave nature, so this is gone. A, B, C. A, B, C. A again does not depend on the wave nature. D, E. D, E actually polarization and interference. This obviously we use wave nature of light to explain polarization and interference phenomena. Okay, so this is also not true. So photoelectric effect, in this actually we use the particle nature rather than wave nature. So only C will be the answer for this question. Okay, that means photoelectric effect is the answer here. Now look this question. Four particles A, B, C, D have masses m by 2, m, 2m, 4m. If they have equal momentum, the particle that has highest kinetic energy is. All of them have the equal momentum. Okay, equal momentum. Momentum means m into v. Okay, and see we can write this as p. Let me tell you what is the relation between kinetic energy and momentum. That is actually k is equal to p square by twice m. K is the kinetic energy. P square by twice m. That means, you know, if p, the momentum, linear momentum are same, then the kinetic energy of all the particles depends only on their masses, and that is actually inversely proportional to the mass. Okay, so kinetic energy is inversely proportional to the mass of individual particles. Okay, then what will be the, so what will be the answer for this question for the highest kinetic energy? Okay, so m by 2 will be the mass which will have the highest kinetic energy, right? Because it is inversely proportional. Okay, so a, body A will be having the or particle A will have the maximum or the highest kinetic energy. Now, this question is again very interesting. Ratio of angle of prism and minimum deviation is 1 is 1, okay, for a prism whose refractive index is 3. That means, angle of prism A and minimum angle of deviation, this ratio has got a value 1. And for that particular prism, the refractive index is given as root over 3. Okay. So the question is then the angle of the prism. Okay, angle of prism, that means A, value of A. What will be the value of A? This is the question. So this is also very simple question. If you remember the formula, mu is equal to sine of A plus delta minimum divided by 2 divided by sine of A by 2. Now I have to find out A, so I can write A in terms of delta minimum in terms of A, right? So delta minimum is equal to A. So this I will put here, so sine of A plus A divided by 2 divided by sine A by 2, right? So here I get sine A, and in the denominator I get sine A by 2. Now we can use the trigonometric identity. Sine 2 theta is equal to sine theta by 2 into cos theta by 2. That particular identity I am using here. Okay, then look, this will cancel each other. Then what we get? We get, sorry, cos of A by 2 is equal to root over 3 by 2. So root over 3 by 2 will be for cos of 30 degree, right? So I can compare this two and write A by 2 is equal to 30 degree. Okay, so from here I can get A is equal to 60 degree. Okay, so what is the value of angle of prism here? That is 60 degree. Okay, so this is the way to get the answer for this question. Now let us see this question. I don't know, I'm feeling that the question was so easy and it will not take even 1 minute to answer each questions. Okay, a bullet of mass 50 gram enters a metal sheet. So there was a metal sheet like this, bullet has entered. Okay, like this, and initially with speed it has, so initial speed 100 meter per second, and emerges, when it emerges out, it has got speed vf is 40 meter per second. The question is the loss in kinetic energy of the bullet. This is very simple question. Loss in kinetic energy, that is delta k is equal to half m v, if I take the mod, okay, mod of that, so initial square minus final square, v initial square minus v final square. So half m is actually 50 into 10 to the power minus 3 kg, and this is 100 square minus 40 square. So very easy to solve this part. See, I can write 25 into 10 to the power minus 3 and this I can write a plus b into a minus b. So a plus b will be 140, a minus b will be 60. Okay, so this will help me to solve it properly. So let me strike this with this one. I have then 10 to the power minus 1, 10 to the power minus 1, fine. So I have, see, this is 14 into 6 is 84 into 25, 25 for the 110, this is 210. Okay, so 210, and here there is minus 1, 10 to the power minus 1, so this will give, sorry, 2100 into 10 to the power minus 1, that will give you 210 joule. So option C will be the correct answer for this question. Okay, now this is another question from the same shift 1 paper, and this is from digital part of the electronics and semiconductor. Find the truth table for the following circuits. So A, B, C, D, there are 4 truth tables given for this particular circuit, like output of the circuit. Okay, see Y is the output, and see the inputs are given A, B in each truth table. So you have to find out the correct truth table for this particular boolean or gate. Okay, boolean gate or the circuit of the gate. Okay, so in this case, look, we have to first write down what is Y, then it will be easy to analyze. See here, A, B, that means this particular output here will be A and B, right? And so this A and B is becoming input for this OR gate, and see the signal A is connected with NOT gate, so output of this will be A bar. Okay, and finally Y will be A and B or A bar. Okay, all right, now see A bar means what? When, see, A bar will be 1 if A is 0, A bar will be 0 if A is given as 1. So this is what is the meaning of bar, as you know. Now we'll have to see how the output, like which one of the truth table is giving the same output. See, when both are 0 0, both are 0 0, so A 0, B 0. But see, for A bar, if you give A is equal to 0, then I get 1. So this particular output is fine. Then if A is 0 but B is 1, so this will give you 0 but this will give you 1. So this is also fine. Then if A is 1, then this will be 0. Okay, so if A is 1, B is 0. So A is 1 and B is 0 means this is 0 and this is also 0. So ultimately you should get 0, fine. Now if 1 and 1, if A is 1, B is also 1, then see, you get 1 out of AB and 0 out of A bar. So you should have got 1. So instead of getting 0, you should have got 1. So that's why this option is not the correct truth table for the given circuit. Now we'll check the other one, B. So see 0. So whenever there is A is equal to 0, you need not see what is there for B. You will get, anyway you will get 1. So this is fine, this is also fine. But this case, if this is 1, B is 0, then it is 0, fine. A is 1, B is 1. See, if A is 1, this will be 0, but B is also 1, A1, B1, so this will be 1. So look this, so all the four operations are actually giving this the correct output. So without going to the C and D options, I can directly say that option B will be the correct answer. Okay, other two options you just check why they are not true. Okay, so option B will be the correct answer for this question. Let me not confuse you with this. Okay, all right, so this is the thing. Now let us go to the next problem. So this problem says a body uniformly accelerates. Okay, uniformly accelerates from starting from zero speed or velocity, starting from rest to a speed of 80 km per hour in time t. Then maintains this speed for a time interval of 3t. Average speed the whole motion. So a body accelerates starting from rest to a speed 80 km in time t, 80 km per hour in time t, and maintains the speed for a time interval of 3t. Okay, then what will be the average speed during the whole motion? Okay, so this is the question. Okay, so we have to answer this question. A body uniformly accelerates, okay, to a speed in time this, okay, to a speed of this. Okay, and then maintains a body uniformly accelerates starting from rest to a speed of 80 km per hour in time t, and then maintains this speed for a time interval of 3t. Average speed for the whole motion. See, whole motion means how much is the time here? Okay, so this is known, okay, 3t, and this is t. Okay, so basically what I have to get, I have to get average speed or average velocity. To get that, actually you have to get, see, there was it stays, okay, stays for 3t and t. So anyway, I know that we have to get the displacements, okay, displacements, total displacement, okay, if I say delta x by the total time interval, that is what we have to get. So what is the total displacement? Total displacement, see, 3t time it goes with speed 80 km per hour into 3t, this will give you the displacement. Okay, and what about this one, uniform acceleration? It actually getting speeded up to this. Okay, so let me get the average speed here. So I have zero speed initially, and I have got 80 kilometer. Okay, so accelerates from 0 to a speed, but it takes some time to go up to this, right? Acceleration is uniform acceleration, but that is not mentioned over here. So that is another point we have to find out how to get that. Okay, okay, so anyway we can get this. Okay, so better not to find out average velocity over here. There is a simple way to find out what is the displacement. Okay, displacement, to find out displacement. Okay, so we need to find out displacement during this time t, right? So s is equal to ut plus half a t square, right? Half a t square. So initial velocity is 0 since it is starting from 0 or rest, and half, what is a? A is actually final velocity, that is minus, sorry, 80 minus 0 by 2 into t square. Okay, into t square. So this will be the s actually. Okay, so I can actually find out from here. But anyway, I don't know what is the value of this t. Okay, that is another point. Then better to go with this v square minus u square is equal to 2as. Okay, a anyway we have got. This is no, this. Oh, sorry. No, then it is all right. Okay, I was writing it here 2, but this is not 2. This is t. So then it is fine. I don't have to go with this. Okay, acceleration we have got this. I'm sorry. So this is, 1t will be cancelled out. So this will be 40t, right? I hope you are not confused. Let me explain you once again. So there are two time intervals. So one is t, another one is 3t. So during this 3t time intervals, the speed of the body was 80 km per hour. So I have got the displacement. Let me write here s1 plus s2. Okay, and let me write this as t1 plus t2. Okay, t1 plus t2. And see, s1 is the displacement speed. So average speed means distance traveled. Okay, distance traveled during t time. So that is what we have found out here. Okay, that is 40t plus s2. S2 is the this one. Okay, this into 3t divided by 40 again. Okay, so then it will be, see, t I can take common and strike from both. This is this into 40, sorry, plus 40 divided by 4. So I get 280 divided by 4, so it will be 70, and this is kilometer per hour. Okay, so this was also a very simple problem, except you get this particular point. Okay, this was little I say mild tough, okay, not very tough. So what is the average speed during the whole motion? That is 70 kilometer per hour. Okay. All right. Go to the next problem. This problem says the time period of simple harmonic motion is given. That is what? This is 3.14 seconds. With an amplitude. Amplitude is given 0.06 meter. With the maximum velocity of the particle is V max. That is given as k into 10 to the power minus 2 meter per second. Okay. All right. So maximum velocity will be where? Let me write down the expression for the velocity first. This will be actually square root of omega square minus a square, I hope. Okay. Let me just write once. Okay, if suppose y is equal to a sine omega t, so velocity will be a omega cos of omega t. That means omega into, okay, there will be omega here, omega into square root of cos of omega t, or yeah, so let this a omega, okay, there will be a also, a omega minus, sorry, a omega into square root of 1 minus sine square, okay, it means 1 minus y square. Okay, so sorry, y square by a square. Okay, so this expression is not correct. Let me just correct it here. Okay, so what I get a will be anyway cancelled, so omega into a square minus y square, omega into a square minus y square. So this is expression for velocity. Maximum velocity will be at a is equal to, sorry, y is equal to 0. Okay, so y is equal to 0, maximum velocity at y is equal to 0, that means it is, so v max is this one, omega into a. This is the maximum velocity. Okay, v max when the displacement is 0, right, at the mean position. Here v max will occur. Okay, so the displacement y is 0 at this position. So now things are okay. Let me find out the value of k. So to get k, again we know omega is equal to, see, we know omega square is equal to k by m, right, k by m, and t is equal to 2 pi by omega. Okay, let me square this out if required. Okay, because I know I need k. Okay, so I think if we get v max is equal to this, okay, v max is equal to k into this. Okay, so V max is equal to omega m. I would not get anywhere. Let me keep this as omega into a. It is there. Omega I can find out from this. Okay, so omega into a. So from here actually I have to compare with this. Okay, let me square it out so that I get omega square is equal to V max by a square, or k by m is equal to V max. Amplitude is given, mass is not given, so why to use this formula? Okay, let me just go ahead with t. That will help me. T square is equal to 4 pi square divided by omega square. Okay, so omega square means this is here 4 pi square divided by t square. Then let me square this out. So omega square is equal to V max square. No, I'm sorry. So anyway, we'll just compare. I'm I'm fine with this much. Let me find out our V max. So this is, omega is equal to 2 pi by t into a. What is a? A is given as 6 to the power minus 2 meter. Okay, and t, we know this is given as 3.14. 3.14, and see pi is also 3.14, so it will be actually 12 into 10 to the power minus 2. Okay, I was actually getting confused whether this k is spring constant. This is no. Okay, this is just a constant, so that's why this value will be 12. Okay, so guys, we are just confused a little bit about this notation k. Notation k is not the spring constant here asked. Okay, it is just a constant. Okay, it is just a constant, that's why the value of that will be just 12. Okay, so the value of k will be equal to 12. Okay, we don't have to worry other things. Okay, all right, so what is the answer? 12 is the answer for this value of k. Okay, now we have got another question. This is very simple question, but this kind of question will be surely asked at least one question. So this is from error analysis from the very first chapter. Sorry, not error analysis, this is from actually the instrument part, screw gauge. Okay, a screw gauge has 100 divisions. Okay, let me write this in to be 100. Okay, with pitch 1 millimeter in the circular scale. So this is the circular division, total number of division in the circular scale, and see pitch is given, pitch pitch is given 1 millimeter. So can I get least constant? Answer is yes. I can write pitch by the end. Okay, that means 1 over 100. Okay, so this is in millimeter. I can write 0.01 millimeter. Upon keeping a wire between start main scale reading is 1 millimeter and 42 coincides 42 coincide circular scale with the division, circular scale division. So 42 circular scale division coincides with the reference line, as you know. So this will give you the circular reading, circular scale reading. So main scale reading, I'm writing MSR SR is 1 millimeter. Circular scale reading is given as 42 into the least constant, that is 0.01. This is also in millimeter. So then it is 0.42 millimeter. Then you have to find out the diameter of the circular cross-sectional wire in millimeter. Let me read. Find the diameter of the circular cross-sectional wire. That means circular cross-section of the wire. Okay. That means the total reading. Okay. Total reading will give you the diameter. Okay. Total reading. Total reading or the diameter itself would be found out from here. What is that? So this is 1 millimeter main scale reading plus the circular scale reading into this least constant. So I have already multiplied. This is also in millimeter. So what you get, the diameter is 1.42 millimeter. Okay, and this is the answer. Look, this first option gives you the answer for this question. Okay, so option A is the answer for this question. Okay, so I'll take up one more question. Okay, let me write down the question first. This is for KTC, kinetic theory of gas and thermodynamics both. The specific heat capacity for a gas following the relation PV square is equal to RT. CV is heat capacity at constant volume, and R is gas constant. So you have to actually find out what is the specific heat capacity for a gas. Specific heat capacity at constant volume you have to find out, or yeah, so CV is the heat capacity at constant volume and R is the gas constant. So options are given. See, that means the question says there is a gas which is following this particular formula, PV square is equal to RT. For this particular gas, what is the expression for the specific heat at specific heat? So CV option B says it is CV plus R, and option C says it is R by 3 plus CV. Option D says it is simply R. So we have to answer the question for this. So we know PV, sorry, here look, T is a variable. So for an ideal gas, if I write PV is equal to RT, right? So if I replace T, then I have to replace with PV by R, isn't it? Okay. So look, if I put the T, value of T here in this particular expression, okay, so we have been given PV square is equal to RT. So RT is equal to actually PV. I can directly write RT is equal to PV for an ideal gas. Okay. So PV by, so PV square by PV, I can write, sorry, let me write it here. R is equal to PV by, sorry, T is equal to PV by R. So this goes. So here it will be PV by PV is equal to some constant, I can say. Here it is 1 anyway, but that is also a constant number, right? Let me write that as constant. Okay, so PV square. So I get V is equal to constant. Okay. So what will be the specific heat over here? The specific heat is actually, see, the one here given is CV. CV is the constant specific heat at constant volume, and CV plus R means CP. That means CP. Okay. Okay. Other things. So this is R, and this, this is R by 3 plus this. Okay. So in this case, since the volume remains constant, I can infer the specific heat to be the specific heat at constant volume, that is Cp. This B option says it is Cp. D says it is R. R is not expression for specific heat. R by 3 plus Cv. This is also not the option. Okay, so option A will be the correct answer for this question. Okay, so with this, I'll stop it here for today. Next day, we'll continue with the remaining question of this shift 1, and the questions from 6th April paper shift 2. Okay, so I'll stop it here for today. Thank you for your patience. Bye for today.